Hi, this is video lesson for 11.4. This is part 1. What I want you to do is go to course documents and print out the class notes if you haven't already done so for 11.3 and 4, and then turn to page 5 and look at the bottom of the page, and let's go ahead and get started. In 11.3, we talked about the slope-intercept form of the linear equation, and that is y equals mx plus b. The m stands for slope, while the point 0b stands for the y-intercept. In this example, we're going to write an equation of a line that has a slope of 2/3 and a y-intercept of 0 and -1. If the slope is 2/3, that means that m is 2/3, and if the y-intercept is 0, -1, that means b is -1. So when we write our slope-intercept form of the equation, we're going to plug in 2/3 for m and -1 for b, so we'll end up with y equals 2/3 x minus 1. Okay, I want you to notice something really important in terms of nomenclature. b is -1, so that if you graphed this point, or if you graphed this line, you would have the x and y axis, you would go to the point -1 and plot a point there. But the point is not -1, the point is 0, -1. So you could say the line crosses the y-axis where y is -1, or you could say the y-intercept, which is the place that the line crosses the y-axis, the y-intercept is the point 0, -1. So on an exam or homework, if you're asked what the intercept is, what the y-intercept is, it is not -1, it is 0, -1. Okay, and let's just go ahead for fun and graph this line. We're going to draw in a few more points. Here's 1, 2, 3, and here's 1, 2, 3. So we start with a point -1, 0, -1, because we're told that it crosses the y-axis at -1. From that point, I'm going to do this, and actually I'll point to it. From this point, we're going to use the slope 2/3 to find the next point. 2/3 means it has rise over run. Slope is rise of 2 over run of 3. So we rise 2, 1, 2, and we run 3, 1, 2, 3, and this is where our next point goes. Let me make it a little bigger. Okay, so that's our next point. So now that we have 2 points, we can draw a line between those 2 points. And so by drawing a line through those 2 points, you've graphed the equation y equals 2/3 x minus 1. So in the top of page 6, we've just shown that to graph a line given its equation using the slope and y-intercept, we put the equation in the form of y equals mx plus b, which is slope-intercept form. And then from that equation, we can find the y-intercept, which is going to be 0, b, and we can plot that point on the graph. The third step is to identify what the slope m is, which is the number in front of your x, or the coefficient of x. Now to graph it, you write the slope in fraction form. So if your line is y equals 3x plus 7, then instead of a slope being 3 for the purposes of graphing it, you write it as 3 over 1. The reason you do that is because you need rise over run. You need to know how far to move up the y-axis and how far to run over on the x-axis. So 3 tells you how far to move up, and then 1 tells you how far to move over. However, very important thing to note is that on a test, you should always write slope as a whole number if it is one. I mean, you write a fraction as a fraction, but for example, if y equals 3x plus 7, then slope is written m equals 3, not m equals 3 over 1. But when you're plotting your line, you need your slope in fraction form so that you know what your rise over run is. So you plot the next point. After you've plotted your first point on the y-axis, you use the slope to go rising over run, and then you find your next point doing that way. And then after you have your 2 points, you can draw a line through them to connect the points. So let's look at this example. Graph the equation 2x minus 3y equals 3. Step 1, we need to manipulate the equation and put it in y equals mx plus b form. By now you should be able to do that, so pause the video and go ahead and figure out what y equals mx plus b would be in this case. Okay, you should have gotten y equals 2/3 x minus 1. Now write what m is and what b is, and then also what the y-intercept is. M is 2/3, the coefficient in front of x. B is -1, and your y-intercept is 0, which represents that x is 0 all along the y-axis, and -1, which is where the line crosses the y-axis. So to plot it, we find x equals 0, y equals -1, and we plot a point there. And then we use the slope, and the slope is 2/3 rise over run, so we rise 2 and we run 1, 2, 3, and we plot a point there. And now we draw a line between those 2 points, and that is our graph of a line. Alright, good practice for you would be to turn to page 815 in your book and do problems 1, A, and B, also number 2 on page 816. In the previous example, we were told what the slope was and what the y-intercept was. What if you were told the slope and a point on the line that is not the y-intercept? Example B, or procedure B, explains what you need to do to graph that line. First, you take the point you're given and you put it on the graph, you plot it. Next, you write the slope that you're given as a fraction, and if the fraction is negative, you assign the fraction, the negative sign, either to the numerator or to the denominator, but not to both. After you've done step 2, then you proceed in a very similar manner to the way we've been doing it above, only instead of starting from the y-intercept, you're going to start from the point that you've been given. So you start from the point you've been given, and then you count up for rise and over for run based on the rise and run of the slope. Now if the slope is negative, then instead of up, you need to count down and to the right. Or you could count up and over to the left. That means that you're going in the negative direction for either the numerator or the denominator. So to reiterate, in step 4, you count up for your numerator and over to the right for your denominator if they're both positive. But if the numerator is positive and the denominator is negative, you count up for the numerator and to the left for the denominator. And if you've made the numerator negative and the denominator positive, then you count down for the numerator and to the right for the denominator. Okay, step 6, you draw a line between the points you've just plotted. And step 7, you substitute the point into the equation y equals mx plus b to find b, the y-intercept. Now this is a new step that we didn't have to do before when we were given the y-intercept. So let's work an example using this procedure. On page 7, we are to graph the line that passes through a given point and has a given slope, and then we are to give the equation of the line in slope-intercept form. So we have the point -2, 3, and we have the slope -4. We're going to do two things. First, we are going to find the point -2, 3 on the graph. So let's look at the graph. And here's where x equals 0, y equals 0, where the graphs intersect. So we want to find the point where x equals -2, -1, -2, and y equals 3, 1, 2, 3, and we want to plot a point right at that intersection. It's hard to do that with this pen. Okay, so now we've plotted this point, and now we need to use the slope to find the next point. But if you look back on page 6, you see that step 2 is to write the slope as a fraction. And when you write a whole number as a fraction, you just put the whole number over 1. So notice I've made my numerator negative and my denominator positive. You could do it the other way around, but let's see what happens when we use this numerator as negative and this denominator as positive. We're going to start at the point we plotted, and we're going to rise -4. In other words, we're going to count down 4. 1, 2, 3, 4. That's our numerator. And then we look at our denominator and we run 1, and we run in a positive direction because the denominator is positive. So that's where we plot our next point, right here. Okay, now all we have to do to graph our line is to connect those points, and we'll pretend that connects them. I don't have a straight edge on this program, but what I want you to notice is that the line is running downhill. Now, since your slope is negative, you want your line to run downhill. So that's one quick check you need to make. If your slope is positive, your line should be running uphill. If your slope is negative, it should be running downhill. I just redrew the line to make it go through those points. So now we have the line, but we don't have the equation in the form y equals mx plus b. Now we do have that the slope, which is -4, but we don't know what b is, so we can take this point -2, 3, and we can plug it in y equals 3 and x equals -2 and see what we get. So we do that and we get 3 equals -4 times -2 plus b, or 3 equals 8 plus b. And if we subtract 8 from both sides, and I'm running out of space, so I'm going to do this right here, we get 3 minus 8 equals b, or -5 equals b. And so we've solved for b. b is equal to -5. Okay, make sure you take those notes. You may want to pause the video because I'm going to erase all of the writing I've just done so that I can rewrite the equation. So the equation for the line is y equals -4x, because m is -4, minus 5 because we found that b is 5. Now to check your work, look at your line. The point where b is 5 is right here at 0, -5. So that line should go through that point. And you can see I don't have a straight edge on my line, but if I did, it would go through that point. So that's to check that your line is correct. Okay, let's work one more example. I'd like you to pause the video and try to work this example where the point is 3, 2, and the slope is 0. Alright, now remember when the slope is 0, we have a horizontal line. So all we have to do is we locate the point on the graph. If you look on page 6, that's our first step. Locate the point on the graph. So we look where x is 3, 1, 2, 3, and y is 2, 1, 2, and there's the point we're going to plot. I'm going to use green ink to do this. I'm going to make it big. Alright, big and messy. And then since our slope is 0, we know it's a horizontal line. So this line is going to be horizontal along where y equals 2. And that's all we have to do to plot that line. And then when we write the equation of the line, we remember that when the slope is 0, the line is going to be y equals some number. Well, in this case, we're told that y is equal to 2. So the equation for the line is simply y equals 2. Okay, I really encourage you to work numbers 3 and 4 on page 817. Let's look back at page 7 of the notes. In the middle of the page, we have to find the equation of the line that is shown in the graph by finding the slope and the y-intercept from the graph. Okay, now if you look at the graph, the line crosses the y-intercept in a strange place. It's not where two lines intersect, so we can't just look at it and decide what B is. We have to figure it out. So we do see, though, that we find points where the line crosses at an intersection. And so if you look up here, you see that where these two intersect, you get the line going through there. So that is where x is 1, 2, and y is 1, 2, 3, 4, 5, 6. So you get the point 2, 6. Okay, let's find another point where it intersects, crosses an intersection, and that would be right here. And at this point, x is 1, 2, 3, and y is 1, 2, 3. So those are our 2 points. Now to find slope, you can either use your slope formula, m equals y2 minus y1 over x2 minus x1. So in this case, here's y2 and y1, and here's x2 and x1. But an easier way to do it would be to just count. We start at this point here, and we count down to this point here. So your rise is going to be negative. We're going to be counting down. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. And your run is also going to be negative. You count 1, 2, 3, 4, 5. So your numerator is -9 and your denominator is -5. And when you write that, -9 over -5, the negatives cancel and you get 9/5, just like if you'd used the equation. The other way you could have done that and avoided negative numbers altogether is by starting at this point, and then you would count up 9 and over 5, and everything would be positive the whole way. Okay, so we have our slope. That means we can start to write our equation. Y equals 9/5 x plus, and we don't know b yet. Okay, now we use the trick we used above, where we have a point. We actually have 2 points. You can choose either of these points and plug it into this equation for x and y. So when we do this, we're going to find what b is. So go ahead and pause the video, choose one of these points, plug it in for x and y, and solve for b and see what you get. If you use the point 2, 6, then x equals 2 and y equals 6, then you get that, substituting for x and y, you get 6 equals 9/5 times 2. X is 2, and when you multiply a fraction times a whole number, change the whole number to a fraction, plus b. Okay, so now we know everything except b, and so when we solve this, let's first look at the fraction. 9 times 2 is 18, and 5 times 1 is 5. So we get the fraction 18/5. I'm going to just circle this and bring it over here. That's going to be 18/5. So now we have 6 equals 18/5 plus b. So we subtract 18/5 from both sides, and here's what that looks like. We subtract 18/5 from both sides, we get 6 minus 18/5 on the left and b on the right. Now let's talk about how to subtract a whole number and fractions. So we change the whole number to a fraction. That's 6/1 minus 18/5 equals b. We have two fractions. We need a common denominator, and that common denominator will be 5. So the second fraction has a 5 in the denominator. To get the first fraction to have a 5 in the denominator, we multiply it by 1, because you can multiply anything by 1 and not change its value. But the form of 1 that we use is 5/5. So what happens is 6 times 5 is 30, and 5 times 1 is 5. So your first fraction becomes 30/5 minus 18/5. And 30 minus 18 is 12, so you find that 12/5 equals b. So in this blank we write 12/5. Okay, now we can write our equation. We go back to this equation, we plug 12/5 in for b, and we get y equals 9/5 x plus 12/5. Okay, now to check that our equation was correct, we plug in our other point. This is the point we use to find b. Let's check, because this point should also make this equation true. So we plug this point in for x and y. That would be -3 for x and -3 for y. And you will find that you end up with -3 equals -3. Go ahead and do that to check your work, because it'll be a good exercise in practicing a little bit with fractions. This is the end of part 1. Continue on to part 2.